Hi everybody, in this video I'm going to go over study section 4.3.1, which focuses on balancing inorganic equations. So the first thing that we need to know in order to balance inorganic equations is we need to know how to count atoms. Okay, so if you have a compound, you need to figure out how many atoms of each element there are. So let's do some examples. Let's say I have BaSO4, barium sulfate. So we use our subscripts to determine how many of each element we have. So if we look at barium, we see that there's no number down here. There's no subscript. And when there's no subscript shown, we assume it's going to be 1. So there's going to be 1 barium atom. Okay? Same idea here. When we look at sulfur, there's no subscript, no number at the bottom of the sulfur. So then we assume that it's going to be 1. So there's 1 sulfur atom. Okay. And our last one over here is oxygen, and we see that number to the bottom right, that's our subscript. Okay, so we have 4 oxygen atoms. Okay. All right, now let's try one more. Let's say water, H2O. I'm doing this one because a lot of us make mistakes with this one. This 2 belongs to the hydrogen, and this nothing, which we can put as a 1, belongs to the oxygen. So that means we have 2 hydrogens and 1 oxygen. I know sometimes we switch that around because you say 2O, but that 2 is actually referring to the hydrogen. It's always, the subscript is to the bottom right of the element, okay? All right, so far not too bad. Now, another thing is to keep in mind is that if there are parentheses, that happens when we have polyatomic ions. You need to distribute the subscripts, and I'm going to show you what that means. Okay, so if we look at an example, let's say we have Ca3PO4 2. Okay, so we have these parentheses here. That means this 2 has to distribute to the O and the P. So calcium is outside the parentheses, so you don't have to worry about that. So we know that we have 3 calciums. Easy. Now, when we look at phosphorus, it would have been 1 because we don't have a subscript, but we have to multiply that 1 by 2. So we do 2 times 1 equals 2 phosphorus. If we look at that oxygen, it would have been 4, but we have to multiply it by 2. 2 times 4 equals 8 oxygen. Okay, let's do one more. Let's say we have MgNO3 taken twice. Okay, so we have parentheses here. So that means that 2 outside of our parentheses has to distribute to the N and the O. So magnesium outside the parentheses, it has no subscript, so it's 1. That nitrogen, it would have been 1, but we have to multiply it by 2. So 2 times 1, no subscript, but that subscript outside you have to multiply by, and you get 2 nitrogen. Now, that last oxygen there, it would have been 3, but we have to multiply it by 2. 2 times 3 equals 6 oxygens. Okay? So this is how we count our atoms. Now, there's one more complication, which is a coefficient. So if there is a coefficient, you multiply all the subscripts by the coefficient. Okay, so what do I mean by a coefficient? Well, for example, we could have something like 3K2O. This 3, that is the coefficient. It's just a number in front of our molecule, okay? So now when we're counting, we say, okay, we would have had 2 potassium, but we have to multiply it by 3. You have to multiply by the coefficient. So we actually have 6 potassium. And oxygen, we would have had 1, but we have to multiply it by 3, so we actually have 3 oxygen. Let's do one more. Let's say we have 2 AlClO3, aluminum chlorate, okay? If we have 2 of them. Our coefficient is this, and we also have to distribute the 3. So this is going to be slightly more complicated here. So, starting with our aluminum, it would have been 1, but we have to multiply by 2. So we get 2 aluminums. Now we go to chlorine. It would have been 1, but we have to multiply by 3, this 3 over here, outside the parentheses, and we have to multiply by that 2 in front. So we have 1 times 3 times 2, which gives us 6 chlorines. Last one is oxygen. It would have been 3, but again, we have to multiply by the 3 outside the parentheses and by the coefficient of 2. So we have 3 times 3, which is 9, times 2 equals 18 oxygens, okay? So this is how we count our atoms. In order to balance any equation, you need to be able to count the atoms, okay? So now that we know how to count atoms, let's get into balancing. So let's say we have hydrogen and oxygen gives us water. All right. So if we were to draw this out, we would have something that looks like this. And if you notice, we have 1, 2, we have 2 hydrogens, and we have 1, 2 oxygens on this side. And by law of conservation of mass, it should be the same on the other side of the equation. And we have 1, 2 hydrogens, so hydrogen is the same, but only 1 oxygen. So we had 2 oxygens on the reactant side, but only 1 oxygen on the product side. So that means this is not balanced. It does not hold up the law of conservation of mass. So we have to balance it. Okay. Now let's show how we would do this. I'm going to show you a little bit different from what they showed in Apex because I think this is going to be helpful. So the first thing I like to do is I like to make the list of all of the elements that I have. So I have hydrogens and I have oxygens. And then I like to count how many I have on each side. So on the left here, I have 2 hydrogens, and on the right, I have 2 hydrogens. On the left, I have 2 oxygens, and on the right, I have 1 oxygen. And I can see here that this is not balanced, okay? So I have 1 oxygen, I need to multiply it by something to get to 2. So what I need to multiply it is 2, because 2 times 1 is 2. So now 2 times 1 is 2, this becomes 2. But this also changes this hydrogen, because it has to, remember, you'd have to multiply. 2 times 2 is 4. So now my oxygen is balanced, but my hydrogen is not. So I have to change something. So now I have 4 hydrogens on the right, but only 2 on the left. So I have to think, what do I have to multiply 2 by to get to 4? I have to multiply it by 2. So I put a 2 in the front here, and then 2 times this 2 gives us 4, and this is balanced as well. Okay, so this would be my final answer. 2 hydrogen plus 1 oxygen gives you 2 water. And if we were to draw that out, we have 2 hydrogens and 1 oxygen gives us 2 waters. okay? And we can count this out. We have now 4 hydrogens on this side and 2 oxygens on this side, and we have 1, 2, 3, 4 hydrogens on this side and 2 oxygens. So we can see that now this obeys the law of conservation of mass. You need to have the same number of each element on both sides. All right, let's do one more example with balancing. Say we have aluminum plus copper oxide yields Al2O3, aluminum oxide, and copper. Okay, I'm going to make my list. I have aluminum, I have copper, and I have oxygen. Aluminum 1 on this side, 2 on this side, copper 1 on this side, 1 on this side, oxygen 1 on this side, 3 on this side. So I can see here that there are actually going to be 2 things that are not balanced, aluminum and oxygen. So a quick tip here is it's good to balance the things that are bonded on both sides before you balance ones that are by themselves on one side. So balance elements that are bonded on both sides first, okay? So we can go back and see here that the copper is by itself on one side, but oxygen is bonded on both sides. So I'm going to start by balancing oxygen. So I have 3 on the right, and I want to have 3 on the left. I have 1 right now, so I'm going to multiply it by 3. So I put a 3 in the front. 3 times 1 is 3. So now my oxygen is balanced. But now my copper is not, because now we have 3 times 1 is 3 coppers, okay? So now I have to go back on the copper side, and I only have 1, so I have to multiply it by 3 to get 3 on both sides. Now my copper is balanced. And now my last step is I'm going to look at that aluminum. So I have 2 on the right, 1 on the left. 1 times what gives you 2? 1 times 2. So you put a 2 in front of the aluminum, and this becomes a 2. And you can see that this is balanced now, okay? So these are just 2 examples. If you're still confused about balancing, there are tons and tons of YouTube videos on this. So just go to YouTube, type in balancing chemical equations, and there will be plenty more examples, all right? But I want to move on to the very last thing that they talk about in Apex, which is ionic equations. Okay, so if we have a regular equation like the ones we've seen so far, it looks like this. And we're going to have our equations of state that tell us if it's solid, liquid, gas, or aqueous. Okay. When we have things that are in the aqueous state, so our sodium sulfate, our barium chloride, and our sodium chloride, what that means is it's going to break down into its individual ions, okay? Because when you put them in water, the ions are going to separate. So now we can rewrite this as what they call a complete ionic equation. And all the aqueous compounds split into ions. Okay, so here, first our sodium ion, we remember sodium is +1, and there are 2 of them. So I'm going to put 2Na plus 1, plus. Okay, SO4, we remember is a polyatomic with a charge of -2. Doesn't have a subscript, so that's all I'm putting there. Barium has a charge of +2. You could find that on your periodic table. Chlorine, we know, has a charge of -1. We see that little subscript there, so we say there's 2 chlorine ions. Okay. Then afterwards, barium sulfate. We notice over here, it is a solid. This is not going to break apart. okay? So I'm going to write this as barium sulfate solid, right? You just keep it the way it is. Now our sodium ion, we know sodium has a charge of +1, and there are 2 of them, plus chlorine has a charge of -1, and because that is a coefficient, remember you have to multiply it by 2, so we get 2 chlorines. All right, so we're just splitting these into their parts. Things to remember here is you need to know the charges, and you need to know if there is a subscript or a coefficient to put the right number of each ion. Okay, so this is our complete ionic equation. Now, you might have noticed that there are some ions that are the same on both sides. So, oops. So this sodium is the same on both sides. We have 2 Na+1s on both sides. We also have 2 Cl+1 -1s on both sides. Okay, and these are what we call spectator ions, because they are the same on both sides. So that means they don't really participate in the reaction. And because of this, we can write something called a net ionic equation. Which is an equation where you remove the spectator ions. And so you only have the elements that are directly involved in the reaction. So we're going to remove those ones that I underlined, those spectator ions. So now I just have SO4 -2 plus Ba plus 2 yields BaSO4 solid. And this would be our net ionic equation. So we took our regular equation, we broke them into all of the ions. Anything that was aqueous, we broke into the ions. We checked we had the right charges and the right number of ions. We identified our spectator ions as the ones that are the same on both sides. And then we remove them to write our net ionic equation. So this is everything we need to know about ionic equations. Okay, so like I said, if you're still having trouble balancing equations, I highly suggest you look up more tutorial videos and try more practice problems, or you can email me and I will answer your questions to the best of my ability. Okay, hopefully this was helpful. Thank you very much.